Welcome to the third video in this short series of mass relationships in chemistry. These introductory videos are meant to show how chemistry is essentially a game of ratios. There's a ratio of the number of atoms of a particular element in a mole, there's a ratio of elements in a particular compound, and in the previous video, linked in the description below, we saw that reactions were linked by a balanced equation, which was the ratio of reactants to products. However, as everybody knows, nothing lasts forever. Even driving a car, you can't drive forever because you're going to run out of gas. In this case, the gasoline, or the electric charge, as the case may be, acts as what's called a limiting reagent. Every chemical reaction is going to have a limiting reagent. If you have more than one reactant, one of them is going to be consumed before the other one. That is the definition of the limiting reagent. Once all of that reactant is used up, the reaction stops. This gives you the theoretical yield, which is the maximum amount of product you can form, or the product formed if all of the limiting reagent is consumed. This leads to an alternate way of looking at the limiting reagent. Very simply, the limiting reagent is going to be the reactant that produces the lowest theoretical yield. How this works can best be shown in an example. Let's say I have a 10-gram sample of nitrogen reacting with 5 grams of hydrogen to form 19.5 grams of ammonia, with a balanced equation saying one nitrogen molecule will react with 3 hydrogen molecules to give 2 ammonias. This balanced equation will be used to determine what is the limiting reagent. Bearing in mind, reagent is a synonym for reactant. The 2 reactants are either going to be nitrogen or hydrogen. As usual, the first thing to do is to convert grams to moles. So for nitrogen, 10 grams produces 0.714 moles. One then uses the balanced equation to determine how much product one could make. With my 10 grams of nitrogen at 2 ammonias for 1 nitrogen, I could make double the 0.7 moles or make 1.43 moles of ammonia. On the other hand, my 5 grams of hydrogen at 2 grams per mole produces about 2.5 moles of hydrogen. The balanced equation tells me I make 2 ammonias for every 3 hydrogens. Therefore, I could produce at most 1.65 moles of ammonia. As the nitrogen produces the least amount of product, the 0.143 is less than 1.65, that makes nitrogen the limiting reagent. Once one calculates the limiting reagent, it is fairly simple to determine what the theoretical yield is. Nitrogen is the limiting reagent because it makes the least amount of ammonia. That amount of ammonia, the maximum I could make if I used all of the limiting reagent, is 1.43 moles. One can then find out how efficient this reaction is. The efficiency of a reaction is called the percent yield. That's calculated by the actual yield over the theoretical yield by 100. In this question, we are told that we actually produce 19.5 grams of ammonia. At 17 grams per mole, that's 1.15 moles of ammonia produced. Out of the theoretical yield of 1.43 moles of ammonia means that this reaction is 80.3% efficient. So essentially, once I have any given reaction, every single reaction is going to have a limiting reagent. As long as you have 2 reactants, one of them is going to be consumed before the other. Once I know what that limiting reagent is by the balanced equation, I can figure out what the theoretical yield is. That theoretical yield, first of all, limits the amount of product that you can form based on the limiting reagent. On top of that, even if all of the limiting reagent is consumed, there's no guarantee that you will get all of the possible product, because nothing in nature is 100% efficient. This concludes the series of videos on how to use mass in determining chemical relationships. All reactions do not just occur in the solid state. In the following video, linked in the description below, we will look at what occurs when a reaction occurs in solution. Thank you very much for listening, and I hope you found this useful.